Hello everyone, welcome to the lesson of vector subspaces. We are considering linear subspaces, also known as vector subspaces. One by one we will discuss here that definition, then theorem, then working rule, questions and solutions, and then checking comprehension. A subspace of a vector space V is a subset which will be non-empty. W of a vector space V. We are considering two sets and which we are considering both are non-empty. Non-empty means at least identity, additive identity, that is 0, should be there. If we are considering 0 there, then both sets will be non-empty. So this W should be non-empty and this should be subset of this vector space V. W is non-empty, at least one element should be there. Additive identity belongs to the set W. For each vector u and v in W, sum of these vectors again will be in W. So we can say for this one, W is closed under vector addition. Now for each u belongs to W, scalar belongs, C belongs to field, scalar multiplication also in W. Jointly these two can be written AU plus BV belongs to W. For all u and v vectors belongs to W and scalars belongs to field. Let us discuss this theorem. If the subset W satisfies these three properties, then W itself is a vector space. So we are considering here this theorem. These are the vector in this vector elements of vector V. Then we are taking span of these vectors elements of this vector space V will form a subspace. So let us check one by one. Identity should be there, 0 vector. Addition of two vectors will be like this one. Let us take u, v, a vector, v be any vector, u plus v will be this one. So we can say that v1, v2, vk, these vectors v1, v2, vk are closed under vector addition. Let us check scalar multiplication. So let us consider v equals to b1, v1 and etc. Linear combination of these elements and multiplying by this scalar v. So CV is an span of v1, v2, vk. So we can say span of the vectors v1, v2, vk is a subspace of V, and span is the smallest linear space of the set contains the set. Now these are some results we will use in our solving numerical problems. So number of distinct k-dimensional subspaces of V equals to this one. The intersection of two subspaces is again subspace. Union of two subspaces is subspace if and only if one is contained in the other. Linear sum of two subspaces is also subspace. These are some results we will use. And let us consider W equals to this is R2 plane, Cartesian plane, and given that x equals to y. So here W is subspace because this satisfies the condition of first condition. For V equals to this one is a subspace. Let us write this in linear combination. So this is the linear combination of the vectors. Let us take V1 is this one, V2 is this one. This is the linear span. So this forms a subspace of V. Again, this is the next question. This is not a subspace because if we put here A is 0, B is 0, then the whole system will not be 0. This is the question. Which of the following are subspaces of the vector spaces of R3? These are the some options. So we can check in these two options A and B. These holds the condition or property of one of our subspace, while C does not holds. Therefore, option A and B are correct here. And this is next question. Let B be the three-dimensional vector space over the field F3 of 3 elements. The number of one-dimensional subspaces of V is, these are options we have to find. This will be the formula. So here we have K is 1. We have to find number of K is 1, N is 3 and P is 3. So using this formula we will obtain 13. This is the answer, correct answer. And these are the some practice questions one can check and solve easily. So one can obtain the answer. This is not a vector space. So here is the answer. And here first is the one can solve these problems easily, and if facing some problem may discuss with us, and if you want some other notifications related to mathematics or higher mathematics, you can subscribe our channel for further notifications. Thanks for watching.